Omni Environmental Inc., USA, Marina Labs, Chennai. He also served in New College as an associate professor and Veltech University, and currently he is working at Wales University. He has numerous innovations in UAV, in air monitoring, 2 air samplers designs, nano sensor for ammonia in air, bio removal, dyes, heavy metals, developed extractor cum dryer, natural face wash, effective microorganisms, and e-thermophilic MS for bio-waste. He also has more than 130 plus publications. He has 107 citations with 16 H index and 26 I-10 index. Now I would like to invite our guest speaker to address the gathering. Please, sir.
Adam was quite wanting for me to come over here because I saw that some of the people on that professor of Veltech Hightech College. Later I moved to Veltech Technical University. Then currently I am working as a professor at Veltech College. Thanks to the management of VT Dept, my personal friend Dr. Yuvraj, who invited me over here to deliver the lecture related to applications of biotechnology. Again, my thanks to Dr. Gnanasekharan, the head of the Department of Biotechnology, PhD, and my work with Dr. Ayyappan and many other faculty members right here. Of course, I am missing them and few more students who are in Wales University already attending the national conference over there. Thanks for inviting me to let me get into the subject directly. Here what I am going to say is applications of biotechnology. Now what is the title? This everybody can get whenever you're Googling. Like just Google it, look for the applications of biotechnology, you will get everything. Between 1 nanometer to 100 nanometers. Or any dimension, it may be X, Y, or this. So this is what the general definition says about things like this. Yeah, here there is a question. How we need to follow the discipline as nanobiotechnology or bio-nanotechnology? So you can get the answer when you are thinking about why they are calling it as biochemistry or microbiology. If I am speaking about biochemistry, it is a chemistry which is dealing with biology. If I am going to speak about the biology, it is a micro-level biology. And that is the same way I am having the disturbance with these two terms. Even you can have an argument with this type. Whether we need to call it as nanobiotechnology or bio-nanotechnology. My opinion, calling it as bio-nanotechnology is better because we are utilizing the nanotechnology, the discipline for biological purpose. Nanobiotechnology in the sense the biotechnology is diminished to the nano size. So I feel that I have opened the arena for you people to have a discussion whether we so here it can be called as bio-nanotechnology or nanobiotechnology. Next slide please. Right, why we need to study about the nanobiotechnology? This again you can get it from Google because the size, penetration ability, surface area, then they change its physical and chemical properties of the advantages when you are working with the nanoparticles rather than the parent material. Where it is used, next slide will be explaining in the next slide. Just think, applying a skin cream or a facial powder. If it is going to be bigger in size, when you are applying the powder and scratching it, you will get your scratches on your face. Then how come we are not getting it? That is because of the parent material, that is the silica, which is made into the nanoparticles, so that it is not forming in the surface. So that's what the general application, because of the size, can easily be used. Next one. Similarly with the carbon black. Next slide. Historically speaking, again you can get who has defined the nanotechnology or how it came into existence and all. But in my opinion, I'm not going to get into those details as it is the Western media which is projecting it. In our one time, in our Indian system, when we have started using this nanoparticles. Next slide please. Sushruta and Charaka. Next slide. They have clearly defined. Next slide. The uses of metal oxides, that is BCE, more than 2,600 years. This is the English translation. When you are doing first typical Sanskrit translation, it is first millennium BCE. That is more than 3,000 years before, we have used the metallic oxides in our own system of medicine. Next slide. Swarna Basma, Loka Basma, Tanga Basma, everything you may be knowing about, even MGR, how much chief minister he used to use, have Tanga Basma. And it's a well-known stuff. White, it is glowing, everything is. So having its own advantages. So nanoparticle or nanotechnology is not new for us. Next one. What is this? What? What is this? Peacock? Feather. Is it having multiple colors? Why the colors? Then next slide. You can see the same fan. Yes or no? Then why they use peacock feather? Instead of that we can have crow feather, crane feather, any bird. Why they opted only for peacock? It's royal, beautiful color. Those colors are exhibited because of the presence of nanoparticles. When they are swinging it, these nanoparticles are coming into the air. Then the king or queen are inhaling that continuously. So that you can see the difference between the general population and the king or queen, their skin getting glowed, continuous exposure. So this is how we have already used the nanoparticles. Right, let's get into the synthesis of nanotechnology. Do you have a paper related to nanotechnology? Say yes or no? No. Even in final year. Electric is there. Okay, right. So synthesis, that's again a challenge. Physical method you can prepare, chemical method you can prepare, but as a biotechnologist, what the world is expecting is they want you to prepare using biological method. So if so, then how we can defend? Next one. If I'm using physical method, I'm not getting the uniformity in size. This is how you can claim and escape. But the fact is different. Next. Chemically, we are using plenty of organic solvent, this and that, some acidic nature, alkali nature, everything is harmful to the environment. By that way again we can escape, but the fact is different. Right, so we have defended ourselves as a biotechnologist. Yes, we are going to synthesize nanoparticles using biological systems. If so, how we can do that? Next slide. This we have started. Actually, I am a specialist on aerobiology, not on nanotechnology. So my doctoral studies is combined with the aerobiology. Everything. My interest is towards the aerobiology. But when I returned from US, my friend Dr. Khalilon, he said, "Macam yang dalam nanotechnology yang very powerful." Nanotechnology. Yang kepada ada facing orang. Right, let us venture into that. So what we thought is, we have started a filtration, amended with silver nitrate. Then we exposed to air. Silver nitrate cost So it's risky. We exposed nearly 400 petri dishes, and the result is zero. Not the noodle side. How many of you know Tamil? Orthan Gutierrez. Finance Minister Arvici. Telugu? Yaar Gutierrez. Only one. Hindi? Okay. இதுதான் எனக்கு தெரியும். வேற இதெல்லாம் மலையாளம் பேச சொல்லுங்க. So we expose and finally accidentally we have a small white colony emerging onto only one plate. Then we thought, okay, let's see what this is. When we are checking what is the reason why we are not getting the colony if possible, we used too much of concentration of silver nitrate. Then we started reducing the concentration of silver nitrate and then we started growing this particular culture. During those days here, many of us are not having the electron microscope of the lab. So we had a collaboration in Australia. So we requested few of the people over there to study about the electron microscopic structure of our bacteria, that is bacillus. Then we got this picture. You can see that the nanoparticles are synthesized by these bacillus. Next one. Then we published this as a paper by the year 2009. Now this particular paper is cited by around 333 scientists throughout the world. Next one. This work we have done in this particular laboratory, right here in Veltech Hightech. My own PhD students, they started working on airborne actinomycins to synthesize the silver nanoparticle. So we tried with actinomycin. Previously we worked with bacteria. Now we want to do with other type of organisms. So we tried actinomycins. And this is what the result. Next slide, please. Next slide. Yep. You can see that the nanoparticles over here are synthesized by 11 nanoparticles. That is, we had a record of synthesizing 5 nanometer size of silver nanoparticle, but they are all amended into the cytoplasm. So how to pick this? How we can harvest this? That is the challenge. So previous slide. So this is what the publication we made. So you can see the first institution, that is Veltech Hightech Technical University, how the students work here, right? Next slide. So this is what the challenge when we are working with the microorganism in synthesis of nanoparticles. We cannot harvest it easily. We need to go for sonication, then we need to get it, cell disruption. Again, when we are boiling it, the cytoplasm gets coalesced. We cannot pick the nanoparticle easily. So this is what the problem when you are working with the biological synthesis of nanoparticles. Then how we can overcome? Then we thought of let us venture into the plants. Next slide. Next slide. Right, we opted for Pycesium aromaticum. Taken the extract. Yeah, here again, plenty of students or people are using the word as synthesis of nanoparticles from Pycesium or from this particular tree. Never ever the tree will synthesize, keep that in mind. If it is so, then we can harvest the trees and we can easily harvest the silver and gold. You know what is the rate of gold now? A gram of gold. Today, we wood level on the Tanga rate is how much? Any guess? 5,000? 5,580 net rate. 5580. So we can harvest it directly. So it is not from synthesis, from any host, using that host. So that's how we are supposed to do. Plenty of papers you can see. So that itself is, will irritate me whenever I am serving as a reviewer. When the paper is coming like this, we get irritated as they are not doing the basic. Also the work may be good, but they are unable to terminate, then this is the problem. Next one. Then we started working with other spices. One day kitchen from Namponi lagi karangi, very important. So spices and culinary herbs. Next one. Practice from amine and compile some effect. Here, just I want you to look into the title. One-step green synthesis of silver nano/microparticles. In the sense, in one of the plant we are unable to succeed. We got only to micro level of size. So what we say is, with ethical reasons, we have given the title as nano/microparticles. Next. Here you can see that the nanoparticles are bigger in size. Even I am recording 362.4 nanometer, which shows that it is as a microparticle and not falls under the category of nanoparticle. Next one. We have started working on nearly 50 different plants, leaf extract particularly, and continuous failure. So we lost too much of money. Then what is the solution? How we can overcome? See, always the challenge forces the scientists to come out of. So this is what the challenge we had. We are unable to prepare using the leaf extract of nearly 50 different things. So what we thought, what the reason? When we are checking and it is the phytochemistry of the plant which is hindering. When I am having the tannin in the plant extract, we cannot expect it to produce the silver nanoparticle. Then we started working with, okay, if it is a plant and if it is processing the tannin, no, we need to avoid the plant, then which part will be better? When we are thinking about this, then we end up with the flowers. Then we started working on using the extracts of flowers. Next one. Right. So we use the chrysanthemum even the chrysanthemum and become enter the color chronology. Coimere is already there, flower marking. But we never went into that level. So what we thought is, for the sound for the pinadi poor Munadi நீங்க டான்ஸ் ஆடுங்க பின்னாடி போடுற பூக்கள் பத்தி just we work with right. So this is what the result. Impact factor is around 7 or 8 for this. So we succeed. And we have used flower synthesis of silver nanoparticles. We thought, okay, we tried with different plants. We tried with flowers of different colors. Again, it's a flop. But I can guarantee you, when you are going to use the flower with yellow color, your success rate is fine. No other color will yield you the typical nanoparticle with silver is concerned. Right, that is what our finding is. Next one. This again is a Google scholar, maybe around the total citation 1704. Of this, more than 1,000 citations came from top 5 papers alone. All those 5 papers are related with nanotechnology. So if I am missing the work related to nanotechnology, my citation might have been only 700. So keep that in mind. So current area of research is towards nanotechnology. So that provided me a base to have 1,000 citations more. Next. Then we never stopped with the flowers alone. We ventured with the fruits also. Currently, I am not revealing the fruit. Stability is a question again. So we had stability of more than 3 years. If I am going to speak this day, I can say the stability is for 5 years. Still, my synthesized silver nanoparticles are stable. After 5 years. 5 years. No, nearly 60 years. Yeah. For 6 consecutive years, this is stable. If it is stable, then the market potency is very high. So this can be used as flow cleaners, surface cleaners, and whatever thing you want. So the stability of nanoparticles. Next one. Again, this is supported by the seed grant of Wales University. Airborne ammonia. Where you can see this in our restroom. Ammonia is coming. Smells bad. Pungent. And few of the industries, ammonia accident is happening. So how come we can measure what is the dose? Because the exposure dosage that determines the health condition of the people who are exposed to that. So we need to find out the dosage of ammonia in such environment. So what we thought is we want to develop a sensor, that is nanosensor which can be used. Nothing is, take the same silver nanoparticle, add known concentration of ammonia, increase it, keep on increasing. You can see that there is a color variation. This can be taken either to UV or a simple colorimeter. When you are going for UV, it costs you 2.5 lakhs. When you are going for colorimeter, it is 2,500 rupees. So which one is better? So using a simple colorimeter, you can detect what is the concentration of ammonia present in the atmosphere of any environment. This is what we have developed. Next slide. So just here I am speaking about the applications. Previously I said how we can synthesize, what are all the challenges, particularly with biosynthesis. I spoke with synthesis using bacteria, actinomycetes, plant material, particularly leaves. Then I moved towards flowers, I moved towards fruit. Right? Right now we are speaking about the application. Application is concerned. You have seen the development of nanosensor. I have used for ammonia, but you can use some other substance also, even EDTA. Instead of silver, we used iron. That we had an excellent result. That is the second type of nanosensor what we developed. Here, you can see that I said that nearly 50 different plants we tried and it's huge failure. In this study, we used around 114 plants. But we haven't taken only silver alone. We have taken the heavy metals. Because when the particle size is more, it is advantage in this case. So when I'm having more particle size of nearly 50 meters, 50 microns, I can easily filter it. So filtration is possible. That is what the principle behind this particular invention is. This is filed for patent. What you are seeing is the first three: lead, copper, and iron. Then we are treated with the first stuff having 7 liters of 1000 ppm metals solution. Second picture and second line shows the treatment with our own product. Finally, you can see that they are getting precipitated and easily can be filtered. Next slide. So the removal percentage, what we are getting is, see, I'm not having any filter system right here. So cost is heavily reduced. Nearly 94.3% is achieved with iron concern. Like that, for different metals we tried and our achievement rate of bio-removal is this. So this is what the beauty. Although it is not falling under nanotechnology, the failure of nanotechnology made me to have this. Next slide. Here my nanoparticles are serving as a catalyst. So what we did, again, the removal of dyes. Why we need to remove? More than 5 lakh people are working in that industry. Their life is at stake when they are closing the polluting unit. So what we thought is right, we need to take it as a challenge, then we try with that. Then you can see how it is removed. Next one. Try with the other one, where you can see the third jar is showing that mostly it is removing. Next one. And then few of the teachers who is coming for the Viva, they are all, you tried it black, you tried it violet, how would the mix of colors? All teachers used to ask, right, whenever they are coming for exam. Whatever we say, no, this is what we did. No, why you are not doing with this? Same thing we thought, okay, why don't we try with 23 different dyes mixed together? Then our technology has yielded 83% of removal. Again, this is other treatment. This is for the first treatment. The cost is concerned 3,600 rupees to treat 1,000 liters of effluent. In US, it costs you around 72,000 rupees. So we have reduced the cost. Next one. What? So, working on nanoparticles, another summer. And the thing will have a wider. What is this? Nothing. முன்னாடி ஸ்லைடு போகி போட்டா அடுத்த ஸ்லைடு பட்டாசுனா வந்ததுன்னா என்னது? இதே மாதிரி ஒரு வாட்டி ஸ்லைடு சிங்கம் போட்டா பிடிக்குங்க எல்லாம். சிங்கத்துக்கும் பிடிக்கும் வித்தியாசம் தெரியல, போகிக்கும் தீபாவளிக்கும் வித்தியாசம் தெரியல. வாட் இஸ் திஸ்? கோவிட் பேச்சா நீங்க? Right. So Diwali. So this is what in Bogi, just plenty of things are being burnt. Then during Diwali, plenty of crackers are burnt. And plenty of what is that? NGOs are saying, hey, you are polluting the environment, you are doing this, that. Don't bust crackers. Move the sound. வருஷத்துல ஒரே ஒரு நாள் தான் கொண்டாடுறோம்.
நடுவில் நீங்கள் என்ன மூஞ்சி take a feeling. கொண்டாடாமா வேணாமா? Then we started working on it. Next slide. Then we have studied the impact of Diwali or crackers on airborne microbiome. Finally, we came to the conclusion it is reducing the airborne bacteria and other ones. In the body of the getting a seasonal change. As a plant pathologist, when I am thinking about that is what the day or the season where plant infection grows much faster. So when you are celebrating Bogi, those airborne microbes are getting settled. So the infection is controlled. This is what our conclusion is. Next. What is this? தமிழகத்தில் 178 இடங்களில் காடுகள் பற்றி எரிகின்றன. ஒரு 4 நாளுக்கு முன்னாடி வந்த நியூஸ். Yes or no? இந்த காடுகள் பற்றி இருந்தா Next slide. What is this? Anybody from Punjab? Haryana? They may be knowing just they are burning stuff after harvesting the wheat. Whatever the leftover, just they'll be burning it. Over what in Delhi, comment as you know. முதல்ல திட்டுறதால இல்லை because of the airborne particles present over there. Next one. These are all the examples what happened when forest fire is happening or when you are burning the stubble. This is what the researchers see. Every year, Indonesia forest, when it is on fire, Singapore gets eye irritation, Malaysia gets eye irritation. Okay? Kannada Tamil, you go Indonesia, eye irritation. So the smoke just there, you can think over here. Next one. Australia and New Zealand, the same impact. Next one. Next one. Chennai to England, Delhi, he travelled to Chennai. Pakkat country edu? Chennai pakkat country edu? Sri Lanka. So he reached even Sri Lanka. Sri Lanka minister on the Viceroy now. Now we are getting his because of Punjab. This is what the beauty of aerobiology as well as the nanotechnology. So we started studying airborne nanoparticles and we have come up with a new term called aero nanosalts. So aero nanosalts is defined by Uday Prakash and Bhuvanesh, my wife of course. Even you can log in, there will not be any word called biosuit. Biosuit is again defined by us. Then we have written a paper stating that as a case study, this is by November 2019, you go into the Bible question. Now you very able to research from next one. Because of a couple of storm, it happened in Peru. The smoke from Delhi reached Chennai, from Chennai it reaches Sri Lanka. Next one. What are they able to feed? Now body money. You may be knowing, right? 11 crore. What is that? Household has been provided by gas connection by this government. Reason behind it, just think about your parents. So what we thought is in India, just plenty of women. Now we Chennai So in these cases, what is happening? When it is coming in as an aero nanosol, what is the status? Then we started working on it. Next slide. அதே குச்சி எதுலாம் எரிக்கலாம் அடுப்புல என்னென்ன குச்சி வைக்கிறோம் இதுவும் தெரியாது சவுக்கு உமா உமா ஊமண்டாரா 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 So one is Casuarina, Prosopis, Malaga actually, Malaga into Vithalan, and young put the blood. Why? Irritation. So this made us, okay, why they are not using those plants? Every அறிவாளித்தனமா they have selected only these plants. How nanotechnology they have studied. Scientists they were on what they did. They were backing up with the scientific data. Next slide. So just these are all the different types of or shape of our nanoparticles. Next slide. Since we started collecting the soup of different plants. Next slide. This is what the same study shows. They are all too small, around 60 nanometers to 150 nanometers. Again, next, the second page is also being registered because of the coalescing of these particles at 200 nanometers to 600 nanometers. Then the third as 1000 to 1200 nanometers. We are registering different peaks. So formation of particulate matter. How PM2.5 and PM10 is being formed. That is because of the aggregation of nanoparticles. Next one. DLS studies. So, graphically scale. When you are checking that it's registering the peak at 200 to 600 nanometers. Next one. Next. FTIR. We want to know whether it is associated with some chemicals or not. We started analyzing these biosuit using an FTIR. You can see plenty of compounds are registered. Next one. காலகட்டத்தில் கொட்டை தனி நடுவில் உட்காந்து ரிசால்வ் தெரியுற மாதிரி ஸோ FTIR different biosuit plants. Next. DLS again. Next. So this is what our conclusion is. Yes, every plant is different. They are chemically different. So why don't we use these things in our business? Then we visited cosmetic of some malls. Then we saw carbon black toothpaste, carbon black facial cream, Elanka facial cream, everything. I meant to discover. ஒரு பன்னாடு தோசையை சொல்லி தரேன். Right. Carbon black. So we thought instead of what we are using, everyone says that it is from bamboo. If I'm thinking about when it is from a medicinally important plant, the same carbon if it is added, it is going to have bigger advantage. It can serve as an antimicrobial as well as a carbon particle. Next one. So we started working with Iconia research. It's an aquatic weed, but when we are studying about these characters, it is free of chemicals. So this can be successfully used as a nanocarrier. If you want to treat cancer, if you want to treat a target-oriented thing, you can use these nanoparticles synthesized from aquatic plants. Because they are not possessing much of phytochemicals, so when I am studying through FTIR, it's nearly 3 or 4 compounds only, then compared to land-based plant, where I am recording more than 14 to 15 compounds. Next one. In the principle used for lava, அயோத்தியில் எப்படி நாங்கள் கோயில் கட்டியும் January or February. The same thing, what we want to do is just let us see. இதே principle use பண்ணி அதை பார்க்க முடியுமா? As an Yarobar, my feel is COVID is யாருக்கும் எத்தனை பேர் ஒத்துக்கிறீங்க? COVID யாருக்கும் யாருமே ஒத்துக்கல. ஏன்னா மில்லியன்ஸ் ஆஃப் டாலர்ஸ் செலவு பண்ணி WHO CDCயும் வயிற்றுல வாயில ஆக்ஷன் சொல்றான் கோவிட் யாருக்கும்னு யாருக்கும் ரீச் ஆகல. Great. For your information, I am the first one to say that COVID is Yahoo in the world. Second, COVID யாரில் இருந்து ஐசோலேட் பண்ணது உங்களோட சூப்பர் சீனியர் from US. She is working for a PhD. Shripriya. She has isolated COVID-19 from Airborne Hospital and she cultured it and showed to the world. இதே Veltech Hightech Engineering College. இது உங்களுக்கு இன்னும் ரீச் ஆகுது. இப்பயாவது கோவிட் யாருன்னு சொல்றீங்களா இல்லையா? அகைன் மூவ் பண்ணிட்டாரா? So my problem is when COVID is airborne, how I can control? ஒவ்வொரு வீட்லையும் வாரம் ஒரு வாட்டியாவது சாம்பிராணி போடுவோம். நம்ம டெய்லி புக் ஸ்டாண்டுக்கு போட்டுட்டு தூங்கிடுவோம். Why this சாம்பிராணி is That is what thought. Next one. ஒரு புது வீடு கட்டினா என்ன பண்ணுறோம்? ஹவன்ஸ். Why we are doing it? சாமி வரும், வந்து அப்படியே தங்கும். சாமி தங்கினா வந்து நீ தங்க மாட்டேன், அது வேணும். So to purify the air, paint smell, to remove those stuff, these nanoparticles are allowed in the form of ovens. You can also call it as microbiology paper machine la lab fumigate பண்ணனும் மிஸ் சொன்னாங்களா மேம்? fumigation again same principle. நீங்க western countries பாத்தீங்கன்னா this is called as smudging. In our term I call it as nanoparticles. Next one. Right, how it is controlled? COVID itself is a airborne nanoparticle because its size is 60 to 80 nanometers. So how the airborne nanoparticle can be combated? By burning. Either it may be samprani or whatever the favorable thing you want. So they form coalescing, grows in size. Control போத்திட்டீங்களா? போத்தி. நீங்க அது கொடுக்கும்போது you can see plenty of black substances falling. Because that is again an aggregation of nanoparticles growing in size, unable to sustain in the atmosphere, they are falling down. If the same is happening, whatever the COVID virus is present, they will aggregate and they fall down. So airborne nature can be easily controlled. Next one. Apart from that, already I said that carbon nanoparticles are having plenty of compounds. Next one. So what these compounds will do? Either they will attack the surface protein so that it denatures. So COVID will not have a chance to sit on your surface. Secondly, next one. Either they may go and reach RNA of the virus, then it denatures. So either it kills the virus, or otherwise it denatures the surface protein or makes an aggregation and makes it fall down. So this is how I have given COVID as an example. This can be applied for any virus. So if you வீட்டுக்கு போன உடனே அம்மா கிட்ட என்ன சொல்லிக்கணும்னா அம்மா வாரம் சாப்பிட்றாங்க போடு. Next one. Further we have studied, we have collected the virus, then we started studying whether it is having an ability to control the bacteria and fungi. Yes, according to the plant species, it is different. Most of them are controlling bacteria, but very few are controlling the fungus. So when they are able to control the fungus, the same thing has an ability to control the virus. This is what the conclusion is. Next one. Nanoparticle. I said that means my airborne nanoparticles are traveling from different countries. Where you go to Talukudima, then the material of airborne, that too of nano size, how come you will prevent that? Impossible. So we have taken this study up to the level of nanobar. Of course, I have published the paper in a conference. Next one. If that is happening, இப்போ நம்ம எக்ஸாம்பிள் வந்து பக்கத்து வீடுன்னு வச்சுக்கோம். ஏன்னா அது அவங்க மேலே தான் நம்ம காண்டாடும். ஸோ இங்கே கொளுத்தி விடும், அவங்க வீட்டுக்கே எல்லா புகையும் போடும். ஸோ if you are doing it in Kanyakumari or Dhanushkodi, it can easily reach Sri Lanka. தமிழர்களை துன்புறுத்திய சிங்கள அரசு ஒழிக பண்ணலாமா இல்லையா? So it reaches Sri Lanka. Then what happens? See, these nanoparticles are having the ability to cross the brain-blood barrier. So they can easily get into the bloodstream. When it is getting into the bloodstream, what will happen? Next slide. Parkinson's disease. It can affect the part of brain. So loses the stability. Next slide. Alzheimer's, the memory part of the brain. என் பேர் வந்துட்டு நானும் தான் இதுக்கும் அல்ஜிமஸ் இதுக்கும் அல்ஜிமஸ் இன்ட்யூஸ் பண்ணலாமா? நெக்ஸ்ட் ஒன். renal system. இதெல்லாம் அவங்க டிடெக்ட் பண்றதுக்கே லேட் ஆகும். But we are succeeding when it was made into what? Generally, என்ன சொல்லிருக்கோம் அப்படின்னா, this can be used as a sensor, this can be used in treatment of cancer, this can be used in drug delivery, or nanofibers can be used as a sensor, particularly with the electronic devices, everything. All these things you can get it in Google. Here I am presenting whatever the research experience I had with my own area of study. Right? Hope that you enjoy. Yes or no? Who antara? అంటే మీరు థ్యాంక్ యూ చెప్పాలని లాస్ట్ స్లైడ్ థ్యాంక్ యూ ఫోటో சொல்லி